I'd like to start with my presentation of the internal seminar today. It is about a joint research project and also involving some transnational activity we worked on for the last maybe 5 to 6 months, and therefore I'd like to present you the VIRCA-NET framework, and which is originally based on some development done by MTA Stacky, and some case study we did in the scope of collaborative virtual product and factory planning. And yeah, this I'd like to present you. Going to the agenda for today for my presentation, I'd like to give you a very brief overview why using distance collaboration is beneficial somehow. I'd like to highlight the link to mechanical engineering, as well as the challenges which occur in this scope. A use case description is given afterwards. This use case description is somehow the basis on which we did some live demo on the CogInfocom conference maybe 1 week ago, which was quite successful, and where we connected over 2 immersive systems in a live demo to the conference, which I think was quite nice to see and quite interesting to see how stable the system works and how easy the integration of different interactive means and visualization means are. Afterwards, I'd like to end with an outlook for Visionaire, how we may use such a system for our purposes. At first, I'd like to tell you something about distance collaboration and why we think distance collaboration is a good mean to tackle some problems while being spatially dislocated but working on the same problem. And I think, so this is our opinion, that it's all about good ideas and how to explain to others. So we have the opinion, we have the view that explaining ideas by some textual means, for example via email or by some even some video conference tools, is quite good, but also a lot of mistakes and misunderstandings occur due to these progress, because textual explanations and are every time a little bit often failures are coming up due to different interpretation of some textures, and therefore we would like to propose some virtual reality enhanced distance collaboration tool by which a shared model is the basis on which collaboration is based, and this is in some aspects better than just a textual basis. For instance, explaining some very special problems is done better in such a virtual way. So we want to take care that such problems don't occur in real-life distance collaboration tasks, so that different parties situated in different locations can talk, can interact with each other, can communicate based on a common virtual model that eases the explanation of different problems so far. So this is quite a very short introduction for the distance collaboration topic. Coming to the link to mechanical engineering, which is mainly the main topic I'd like to refer to for today. It is to say that mechanical engineering projects in this type, we specially focus on production planning or factory planning, is highly complex and multi-domain problem. On the one hand, different levels of a factory must be considered. For instance, we can go from a very top-level domain like production network, and we can focus on even smaller sections of the whole system, so that at the end, even a single workstation or a single workplace must be considered when planning a factory. So we have a very, very complex problem dealing with lots of different points of views, lots of different tasks itself. On the other hand, the involvement of various number of stakeholders, is even extending the problem. So in today's factory planning processes, not always production engineers are involved, but also management. The management must be involved to ensure the whole planning process, to ensure top-level strategy involvement in each step of the factory planning, but also various number of other domains of other departments in the factory must be involved in this progress to make factory planning, to ensure the success of factory planning. So we have problems like different points of view. Different departments are objecting have other personal objectives. For instance, logistic guys want to ensure a smooth transition of material through the factory. Maybe some security department is more interested in, is the production we plan secure, and therefore people talk at cross purposes, how we call it at this point of view. We have different know-how and different experiences of planning participants, which they bring in due to their gathered experiences in former projects, and all these have to merge together because problems are very complex. It is not suitable that one single person solves the problem due to his specific point of view. So several domains are needed to be involved because they all have to work with the planning results afterwards. And to integrate these different people is nowadays even more complex because different entities, different departments of multinational companies are not located at one single spot, but are more or less distributed all over the globe, especially when planning needs to involve some external partners coming from some supply chain network. This distribution problem gets even worse. So therefore, we propose a virtual reality enhanced factory planning framework to ease the collaboration within these tasks. To give you a short idea of what a typical setup can be, for instance, this is the typical setup we had on the conference last week. So we have some local production, which is placed in Košice. This was initially the part of the location of the conference itself. We have here in Kaiserslautern, for instance, some machine tool distributor, and we have in Budapest some robotic specialists. Each of them is distributed all over the globe, but they have to work together because every location has its own special experts, has its own special expertise. For example, local production guys are very focused on the local constraints coming from the building itself, coming from the people working in the production line. Some machine tool distributor, on the other hand, has very, very detailed know-how and very detailed experience on the machines you would like to use. And in this use case, a robotic specialist is involved, which is very skilled in using robots, which is very skilled in programming the robots, but has no idea, or more or less no idea, what the robot should do in the local production. So we bring these three people together in some virtual shared space, just as if they were sitting together on one computer and talking on the same digital model. Because this is the idea we have. If the whole process, as seen on the left side, is placed in one location, the problem is complex to solve, but it's possible. It's possible because the planning participants already learned how they should work together. They have some very basic idea of the workflow, how it should be done in one place. Now we try to adapt these already existing workflow, which is already learned and already used by the planning participants, and transfer this workflow to the virtual reality to make it possible that even when people and entities are distributed all over the world, they could work on some shared model. They could interact with user-machine interaction, and they could interact between users itself. So these 3 points are identified as crucial for this adaptation of the workflow. These 3 points are crucial for the later on application in the VircaNet framework. To go a little bit deeper into these 3 crucial points we try to tackle with the VircaNet deployment, I'd like to go now. The first challenge is the shared visualization. As I already said at the beginning of the presentation, this visualization of problems is a very easy way to communicate problems, to communicate single challenges which are occurring due to the factory planning. As shown in the slide, a picture is worth 1,000 words. It's very easy understandable that when I talk about this machine and this corner of the room, it is very easy to understand by each planning participant in comparison to describing with email which special point of the production layout I mean. So we need to share some common model so that, as shown in this slide, people in Kaiserslautern and people in Budapest have the same model, have the same views on the model, and have the same output on changes to the virtual scene. So this is one first basic pillar which was solved by using the VircaNet framework, that we can enable a common model distributed for 2 worldwide distributed separate full immersive systems. The second challenge was the user-machine interaction, because for analysis of the virtual environment, we think it is necessary to interact with the virtual model itself. It is necessary to change the model. For our use case, this changement of model is more or less based on reorganizing the layout, reorganizing machine positions. But going deeper to the use case, also the reactions to the model behavior must be visualized. This can be easily understood for the use case of the robotic specialists. So for all planning participants, the behavior of the robot is visualized and is some feedback. So everybody in the whole setup has the same perception of this robot, how it's moving in the real world and how it's moving in the virtual world. The feedback among hardly visualizable effects is part of this user-machine interaction, we think, but this is a point we will focus for the upcoming research. The third challenge is the user-user interaction, because we think it is very crucial to bring people together, to available some direct communication via speech transmission, for example, but also to allow some indirect communication. For instance, if I move one object from one to the other side of the room, I can support my communication among others with this very simple step in changing the model. We also have the idea that the integration of knowledge and know-how in such a setup, in such a framework, is done in the best way by some brain-in-the-loop process. So we like to bring people together and we like to make them solve their problems while using their brains, as if they were sitting directly to each other. So this is also one interesting challenge we like to tackle with the whole setup. As already described, we had to test out and to show the capabilities the worker system is able right at the moment. We had some live demo during the CogInfoCom conference last week. Therefore, we had the use case description as already described in a very rough way. We had some machine tool distributor which was focusing on machining constraints, who has very detailed know-how in machines in real life, and who was interested in how to integrate his machine in the whole shop floor of the factory. The local production was represented by the conference itself, and the robotic specialist was one planning participant, one partner who was connected coming from Budapest directly. So we could establish this this live connection. We could establish this demo among the usage of some virtual reality enhanced distance collaboration tool in the scope of mechanical engineering, and I think we will also go further with our joint research activity and with our transnational activity to detail out the capabilities such an virtual reality enhanced collaboration tool will have for the factory planning topic at all. But nevertheless, I think this demo we had on the conference was some very suitable example to show how it is possible to couple two full immersive rooms